Verifying trigonometric identities. What we're going to be doing in this section is taking trigonometric identities and verifying them using the fundamental identities that we worked with in our last video. So if you have not yet watched video 5.1, please press pause on this video and go back to video 5.1 where we go through all of the different strategies for using those fundamental identities. In this video, we're just going to take it a step further to verify that two sides of a trigonometric identity are the same. So we're going to start with one side of the trigonometric identity and use our fundamental identities to end up at the second side. We're going to show that they're equal using those identities. For instance, and let me start by saying there is more than one way to do each of the questions that we're going to look at today. So I am going to take you through one or possibly two ways to do a question, and you might have done them using a different method, and that doesn't make it incorrect, as long as your mathematics are sound. For instance, if I start with secant squared theta minus 1 divided by secant squared theta, I'm trying to get that to turn into sine squared theta. So one way to do that is to rewrite the numerator using tangent squared theta, that is the Pythagorean identity. Secant squared theta is in the denominator, so that means this could also be written as 1 divided by secant squared theta. So if I do it in that method, then I can rewrite 1 divided by secant squared theta as cosine squared theta. Now again, I'm trying to get to sine, so I'm going to rewrite tangent squared theta as sine squared theta over cosine squared theta, and then I'm going to simplify by dividing. Now, is that the best way to do it? No, it's not. But is it an okay way to do it? Yes, it is. So let me show you another way, just for fun. If I start with secant squared theta minus 1, I can write that as secant squared theta divided by secant squared theta, and then minus 1 divided by secant squared theta. This turns into 1 minus 1 divided by secant squared theta is cosine squared theta, and then I can use the Pythagorean identity to rewrite that as sine squared theta. So which way is more correct? Well, they're both correct. Which way do I prefer? Well, this one's fewer steps, so I prefer that. But either way, you're going to get the correct result. I would like for you to verify the trigonometric identities given on your screen and do it in whichever way that you feel best. Keep in mind that you're going to start with one side of the equation and work it to the other side of the equation. So if I wanted to start with secant of x and turn it into tangent of x times cosecant of x, I could. If I wanted to start with sine of x divided by 1 minus cosine of x and turn it into cosecant of x plus cotangent of x, I could, or obviously go in the direction that it's written. So I want you to try both of those questions. Just get as far as you can, and when you're ready, press play to see how you did. For the first one, I decided to start with tangent of x times cosecant of x, and I rewrote tangent of x as sine x divided by cosine of x, and cosecant of x as 1 divided by sine of x. I did that because I knew I would then be able to divide. So now I have 1 divided by cosine of x, and we all know that 1 divided by cosine of x is in fact secant of x. For my second equation, I started with the second side. So I started with sine of x divided by 1 minus cosine of x. I took that times 1 plus cosine of x on the top and the bottom, again because I'm looking at the opposite sign. If I multiply that out, I get sine of x plus sine of x cosine of x, and then in the denominator I have 1 minus cosine squared of x, which I'm going to replace with sine of x, sine squared of x. I'm going to write it as two separate fractions again, and then reduce each fraction. So the first fraction, sine of x divided by sine squared of x, is 1 divided by sine of x, and the second fraction is cosine x divided by sine of x, and then using those reciprocal identities, I get cosecant x plus cotangent x. For our last example, I wanted to go through a question where instead of turning the first side into the second side or vice versa, I turned both sides into the same expression. So the trick here is that you have to know when to stop, and you won't really know when to stop until you've done some practice on this. So for instance, for my first question, for my first side of the equation, I'm going to look at the Pythagorean identity using tangent squared x. So I'm going to rewrite tangent squared x as secant squared x minus 1. The denominator remained the same. For the numerator, that's a perfect square minus a perfect square. So it's secant x plus 1, secant x minus 1. And then the denominator, I'm simply going to switch the order so that instead of 1 plus secant x, I get secant x plus 1. And of course I did that so that I could reduce. And then I got it down to this point and I thought, I'm going to stop right there and see if I can turn the second side of my expression into secant x minus 1. So again, I started with 1 minus cosine of x divided by cosine of x. I decided to write that as two separate fractions. So 1 divided by cosine of x minus cosine of x divided by cosine of x. 1 divided by cosine of x is secant x, and cosine divided by cosine is 1. And notice both sides are now into the same format. Coming up next, all of your hard work will pay off. We're going to look at solving trigonometric equations using strategies we learned in 5.1 and 5.2.